such that an plus 1 is bigger than or equals to an minus 2 power n for all n belongs to n. So which of the following is true? First one, an diverges to plus infinity. Next, an diverges to minus infinity. Third one, an converges. D is n is bounded. Yeah. Use chat box. Tell me your option. You are given that n is a bounded sequence and n satisfying the inequality. Its answer is right. See, do in your notebook, then solve. Try to tell your opinion. Okay, Pandu responded and Shivakumar also responded. Minus no 1 by 2 power n. This is 2 for every n. Right? So therefore, already I told you, whenever you are given a problem, whether it is increasing or decreasing, what you do is that try to estimate an plus 1 and minus an. So therefore, compute an plus 1 minus an is always non-negative by the condition. Right? So I don't see what you know about an, just about an is actually bounded. That's it. I don't know about an. Just that an is a bounded sequence. So you have a 1 by 2 power n. But I need to know that whether it is increasing or decreasing. So what I do is that adding and subtracting 1 by 2 power n. This is a trick for the problem. Right? So therefore, what you get, this is an plus 1 minus 1 by 2 power n. This is nothing but what? This and this. 2 by 2 power n minus an is non-negative. Right? So therefore, an plus 1 minus 1 by 2 power n. This is nothing but 1 by 2 power n minus 1 minus an is also non-negative. Therefore, an plus 1 minus 1 by 2 power n minus an 1 by 2 power n minus 1 is non-negative. Therefore, what you observe is that suppose you take this as a sequence. So bn plus 1 minus bn is non-negative, where what is my bn? My bn is an minus 2 power n minus 1. This is my sequence. So what you observe is that this shows that bn is an increasing sequence. So bn is a dummy sequence. Bn is a dummy sequence. It's not my original sequence. What is my original sequence? An is my original sequence. With the help of an, I can create a dummy sequence which is called as bn. Right? Bn I know because an, you're given an, and you know that actually what is the information about 1 by 2 power n minus 1? You know that because this is a fixed sequence, 1 by 2 whole power n minus 1. So therefore, I know bn. Right? So it is increasing, and you know that is it bounded sequence? Yes, it is bounded. So this shows that it is increasing. Is it bounded? Yes. Why? Because what is my bn? My bn is an minus 1 by 2 power n minus 1. This is bounded. You know that you are given that this is bounded. This is bounded. And you know that 1 by 2 power n minus 1 also bounded, because 1 by 2 power n minus n equals to 1 means what? 1. N equals to 2 means what? 1 by 2. N equals 3 means what? 1 by 2 square. Like this going on. 0. So this sequence also bounded sequence. Sum of bounded sequence is always bounded. We have seen in basic arguments. So therefore, what is my Bn? My Bn is a bounded sequence. Therefore, Bn is increasing and bounded. Again, one can apply Montan convergence theorem. By Montan convergence theorem, Bn converges to some real number as n tends to infinity. So once Bn is convergent, what is my Bn? My Bn is nothing but what? Limit n tends to infinity, Bn is equals to L, because L is the limit of the sequence Bn. But what is my Bn? My Bn is nothing but an minus 1 by 2 whole power n minus 1 is equals to L. Therefore, this converges to 0, we have seen. So limit of n tends to infinity, an minus, this is convergent. I don't know whether it is convergent or not. So therefore, what is this limit of? This 1 by 2 whole power n minus 1 is equals to L. This converges to 0. Therefore, limit n tends to infinity, an minus 0, because 1 by 2 whole power n minus 1 always converges to 0. So therefore, this is equals to L. Therefore, limit n tends to infinity, an is equals to L. Therefore, an is a convergent sequence. An is a convergent sequence. What is my n? My n is a convergent sequence. Or else, this is one way approach. Second way approach is using this idea, an is nothing but what? Bn plus 1 by 2 power n minus 1. We have shown that Bn is convergent. We know that this is convergent. Sum of convergent sequence is always convergent. So therefore, an is convergent. That's it. Understand? You can use this technique or this technique. You can go through it. So an is nothing but what? So this is interesting example because by which you are given a sequence an, I don't know about Bn. What I do is that create a dummy sequence Bn, with the help of dummy sequence. We have shown that an is a convergent sequence. An is a convergent sequence. Yeah.
Sir, already
is equals to half into an plus 1 for n equals to, suppose you take 1, 2, 3, 4 going on. And you are given that where see this iterated sequence starting from A3, A4, A5. So therefore, what you do is that A1 and A2 are given. Right? So which of the following is true? First one is an is increasing, an is decreasing, an is not increasing, not monotonic increasing. D is an is monotonically decreasing. Yeah. So this is a very interesting problem. So tell me your opinion in group chat box. Because you're not given actually A1, A2, A3, A4 like this, because they are fixed numbers. They are not, A1 equals to something 1, A2 equals to 0. This is like, an plus 2 is equals to half into an plus 1. You are given that A1 and A2, which are given. I don't know about A1 and A2, really. Right? So anyone? So tell me your opinion in a group chat box. A1, A2 are given. This you are given. And an plus 2 is equals to half into an plus 1 plus an for n equals to 1, 2, 3, 4 going on. Right? So what you observe is exactly, what is this actually? Is, sum of these two. That means what,
AP.
what is my A3?
Half into A1 plus A.
So arithmetic mean of this three real numbers. That means what? A3 is nothing but what? A3 is equals to A2 plus A1. Right? A4 is equals to what? Half into A3 plus A2. Like that you are going, right? But using this idea, I'm going to just do it. Suppose, so there are options, they are real numbers. A1, A2 are real numbers. I don't know real about if they are A1 equals to 1, A2 equals to 2, A3 equals to something. I don't know about this. But what you do is that there are two possibilities. You are given A1, A2. That's it. So there are two options actually. Three options by trichotomy property, because we are working with the real field. It's an ordered field, in fact, a complete ordered field. Either A1 equals to A2 or A1 less than A2 or A1 is bigger than A2. Right? Once you take A1 equals to A2, that means A3 is nothing but what? A2 plus A1 by 2. And that means what? This is nothing but A1 plus A1 by 2. That means what? A1. That means A3 equals to A1. Again by induction, A4 equals to 1. A5 equals to 1. Therefore, what you observe? An is a constant sequence. Constant sequence. Right? That means constant sequence like A1, 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 like this. This always converges to A1. So whenever A1 equals to A2, the sequence is always convergent. That means An is a convergent sequence if A1 equals to A2. So what is the next feasibility? Our next feasibility is if you take the condition A1 less than A2, that means suppose you take adding and A1 on both sides. What you get? A1 plus A2. That means what? 2A1 is less than A1 plus A2. That means A1 less than A1 plus A2 by 2. That means what is this? Actually A3. Therefore, A1 less than A3. Similarly, add A2 on both sides. What you get? A1 plus A2 less than A2 plus A2. Therefore, what you get? A1 plus A2 by 2 is always less than A2. That means this is A3. A3 less than A2. Therefore, A1 less than A3, A3 less than A2. Just combining these two equations. Similarly, this is what is arithmetic mean. So what you observe, A1, A2, when you're given A1 less than A2, their arithmetic mean lies between A1 and A2. Understand? If A1, A2 less than A2, their arithmetic mean lies between A1 and A2. That we have shown, right? So applying the same thing by induction. So these are two consecutive terms. So their arithmetic mean lies between them. What is arithmetic mean? A4 lies between this. Right? Again, these are consecutive terms. Again, and their arithmetic mean lies between them. Right? Again, these two are consecutive terms. Therefore, their arithmetic mean lies between them. A6. So what you observe is that this is neither increasing nor decreasing. Not decreasing, because A1 less than A2, A1 less than A2, okay. But A2 cannot be less than A3. A1 less than A2, okay. But the thing is A2 cannot be less than A3. So therefore, this is neither increasing nor decreasing. This is a typical sequence, right? So it's neither increasing nor decreasing.